Yes. All right, good morning. And welcome to the first day of testing. Um, Today we do a simple introduction to testing, what it is. Just get the basic concepts down, right? And introduce the tooling that we're going to use for the rest of the week, at least part of it. And hopefully show some of the benefits of writing tests. Um, like everything in our industry, you're gonna find people in favor and against some of the things that we're gonna talk about today, but just learn the basics, try to understand it yourself, and come to your own decisions when it comes to how do you approach testing in your projects. I see that everyone has the project already cloned. There's nothing there. There's no package to install or anything. We're just gonna start writing some code together. So I'd like to start not by showing that, but by talking about today's challenge, because it's hard. It's a really hard exercise. But hopefully, as you walk away today, you'll have a way to write 5 or 6 tests for it, and your PMs are going to consider that if the tests are testing the right thing, that's going to be considered MVP. Okay, but it is based on an actual game that exists, right? And the idea here is you're gonna write unit tests, but also the implementation code, both things. You're gonna implement a couple of things based on interviews that happen with clients, potential users of the system, and they gave us some requirements for it, right? So we're gonna see what the requirements are, try to understand the rules as part of the exercise, and then you see, okay, what test can I write for this? You will see quickly as you learn this that the syntax and actually get into use with the documentation, which is really good, you find anything, most of the things that you want to test, you'll find ways of doing it because the documentation is so good around the testing framework we're going to be using. You'll find that the hardest thing is, what should I be testing? We're going to do our best to give you some guidelines that you can follow for this, but just know that it's going to be hard, and it's going to be hard today, this week, this month, and probably this year and next. Probably within the next 5 years, it's still going to be hard to figure out what should I be testing for a particular piece of software. So keep that in mind. It's not something that you just learn and that's it. Sorry. It's something that you will get more comfortable over time, but I don't think anybody ever gets to a point where they see a piece of software and they immediately know all the things that they need to test about it. I think it's something that you kind of start with the easy stuff and then you start adding tests as they come to mind. Okay. So what to test is the only hard thing this week. That's it. The rest, you'll be experts on syntax and all that by the end of the week. Well, maybe not experts, but you are going to feel really comfortable about writing tests. So what about this project? Well, we're going to ask you that you kind of read to the README. That I know it's hard to read READMEs, but please read this one because it's going to tell you kind of what it is about. It's a game. It's an online game. And the game, you have items, as always, and you can enhance those items, make them stronger, right? So what you are going to be writing is you have this enhancer.js file inside here, enhancer, and this spec file for the tests, right? So inside of that, inside the enhancer.js, you're gonna implement the requirements, and in the spec.js, you're gonna write the unit test there. Okay. Now the idea is from this code, you're gonna export an object, and the object is gonna have a few methods: repair, success, fail, and get. Your job is to understand what those methods are supposed to do, so you can write tests for them. Okay. Now, the first one says repair, and it's going to take an item. An item, think of it as an object that has some properties in it, right? And an item is going to have a name, durability, and enhancement. The enhancement, the name, we know what it is, right? The enhancement is a number that goes from 0 to 20. And the item's durability is a number that goes from 0 to 100. Okay? Now, we say that this item thing, when you call repair and you pass an item, what you're going to do is set the durability to 100. Doesn't matter what it was. It's just going to spit out a new item. So it's going to take the item that you give it, and it's going to return a new item with only the durability change to 100. So this is a good starting point. Sounds like it's something that is easy to test. Cool. Now, you can also have a success and a fail, and also a get. But the get is only if you're working on the stretch problems. So we're going to concentrate on the success and the fail. When the enhancement succeeds, meaning you're going to be calling that success method, there are some rules here. Like the enhancement is going to increase by 1. If the item enhancement is 20, the enhancement level is not changed because you can only go up to 20. And the durability is not going to change, right? Those are the 3 rules when everything succeeds. When enhancement fails, though, the enhancement level, if it's less than 15, it's going to decrease by 5, the durability. If the enhancement is 15 or more, the durability is going to decrease by 10 on every failure, okay? Now, can it go below 0? Nope, it's from 0 to 20, for 0 to 100 on the durability. And on the enhancement level, it's gonna go to a max of 20, remember that. Now, if the enhancement level is greater than 16, then the enhancement level is going to decrease by 1. Meaning that if you pass an item with an enhancement of 17 and you call the fail method with that item, it should return an item back that has less durability and goes down to 16 on the enhancement level. Okay? So those are rules for you. If it was 18, it goes down to 17. When it's going back in enhancement, the lowest that it can get is 16, right? Because it says it only happens if it is greater than 16, 17 and up. Why is this exercise? This is to be a lot harder. We have been taking input from you, from the students, and making it a little, making it require less work, right? So that you could do it within the 3 hours on the afternoon, 3 or 4 hours. So there's a stretch problem. If you finish it early and you think that you have all the tests that you can write, you could try this optional section there. There's a little more in here. So this should keep you busy for the rest of the afternoon. If you do even write tests for the stretch, because this is something you've done before, and you're familiar writing tests, and it feels natural to you, there is another repository here with the old testing project that has a whole bunch of JavaScript functions in there that you could go and test. So in this project, you have basic JavaScript files in there and advanced JavaScript files in there that you could go and test, like for instance, arrays or objects. If you check out the objects, you're gonna see a whole bunch of functions in there. You could test those. There's also some functions that handle arrays. You could go and test those. So there is plenty for you to test when it comes to testing JavaScript functions for today in the afternoon. Questions there? This is a good exercise because this is something that is not common. There's something that unless you have played this game or something like it, you're not gonna understand what's going on. So it's gonna be forcing you to understand something that is totally new for you, and at the same time write the test for that and implement the code for that. The code is not gonna be particularly hard, but it requires that you kind of understand and can read through the requirements to understand exactly how the system should work. I see no questions. That's a good sign, right? That means that seems clear enough, right? Your PMs suffered, went through this exercise, so they can answer questions for you, no problem. Now, the project for today that you all have in there, we're gonna start from scratch and add some code in there and kind of get the basics of how testing works. But before we do that, Let's answer those questions that you're gonna have, and you're gonna read. Hear people say, "I don't test because it takes extra time. I don't test because this. I don't do TDD because this other thing." Okay. Someone's losing their internet connection. Yeah, it happens. It happens. So there were some content in there in training kit. Some I shuffled around from over the weekend, but everything that you need is gonna be here. So why automated tests and what are they? Well, let me come clean right now and tell you the absolute best way of testing your software is using manual testing. It's running it and testing every scenario, passing different data, see how the system responds, look at how it's displayed, if it's something that has to display, if it's a report, looking at the report. Manual testing is by far the best method of seeing if the software works well or not. However, it's time consuming, okay? Especially as the system becomes more complex and it's got a lot more features. Testing everything every time you do a little change to make sure that you don't break anything becomes very, very time consuming. So what do? We automate part of the process, okay? So this week is going to be about automated testing. But even then, automated testing can be broken down into different types of tests. Some of them are more are expected that the developers do. Some of them are going to be done by someone else. So since this is a web development course, we're going to concentrate on the stuff that you as developers are expected to write. Which tests are supposed to be your domain, under your under things that you're supposed to do, your duty, your duty as a developer. Okay. But why would you want to do that? Okay, automated testing. I understand that now. There's software that is going to help me test my software. But why do I want to do that? Well, what do you think? What about if I make a stop here and say, type what you think is a benefit of testing and don't submit it until I say go. Let's do that exercise. And tell me what you think. Why you think testing is good? Start now. Start typing it. Let me see if I see a few people typing there. See several people are typing. Yeah. Why is it good? What benefits can we get out of adding some automated tests to our software? Let's see what you got. Go. Drop it there. Fixing bugs. So let me see real quick. Oh man, this is gonna be a tough day. Good experience for the user, very, very important, right? Production ready, knowing that your code is production ready, finding bugs, fixing bugs, catch unexpected bugs. Making sure those developers don't break the code. You can refactor the code and, without breaking things. Confidence in our code. Save time in the long run term. Yep. All of those are correct. Exactly, right? One of the things that sometimes we have like short-term vision, right? And we only see and say, now I have to write more code, so I'm going to go slow. Yeah, that's on the short term. But on the long term, it's going to save you so much time and so much grief. Look at how the first one, I like the first one, it says, protecting the user experience. The absolute best way of getting rid of all your users and making sure that they do not use your software is by introducing bugs in it. So that people get frustrated and they click a button, they think something's going to happen, something else happens. That's a sure way of putting your company down the drain, right? So what do we do? The other way, the other thing. We'll make sure that our software is working correctly. So you're looking for correctness, okay? You're looking for a good experience for the user in a way of the system behaves as intended, right? No surprises. But for you as a developer, I saw some of the things that you said there, I'm just repeating your stuff, is it's going to give you confidence on the code. It's like you're going to hear it called a safety net. And the idea here is, remember that refactoring that we mentioned? When you can change the way that you implement something without breaking the functionality? Yeah, you could do that because now something is going to tell you if you break the functionality. And if you only have 5 features on the code, it's easy for you to change something and go and check the 5 things. What if it's a complex software that have 500 features? And each one of those features might take different kinds of inputs. So you have to test them all. But if that happens real fast in an automated test, you can now, without having to have that nagging feeling of, did I break something? Did I break something? Did I break something, right? Because you're going to get that. And here's what's going to happen. Testing, for some people, maybe not everybody, for some people, once they try it, it's like wearing a seatbelt. If you're always driving with a seatbelt, when you have to drive in a car that has no seatbelt, you feel like unsafe, like something's missing. It's the same with testing. So hopefully at the end of the week, when you have to write some code and you're like, I have no tests, oof, you're gonna get that nagging feeling like, what did I break? What did I break? By the way, sometimes you change something over here and something down here breaks. And you're like, but I worked up here. Why is this down here breaking? Well, that's called a regression. Whenever something that was working, it doesn't have to be in the other corner, but every time something is working and you change something unrelated to that, and then something stops working, you introduce a regression. Some people say that regression is when you had a bug and you fixed it and then it comes back. I would say anything that takes code that used to work, and by you adding a new feature or making some change unrelated to that, breaks that code that used to work, I call that a regression too. Okay? So we want to minimize the chances of introducing regressions into our code. What if I don't want to test? Well, you go through this manual testing, you're going to have bugs, and of course, the code is harder to understand. You'll see also that having a nice code base of testing, a tested code base, those tests are going to kind of describe how your system works. Because if you're covering your software completely, you will see how every feature that you have is going to have tests for it. And it's going to tell you exactly how the feature is supposed to work. If I give it a 0, I expect to get empty string. So now you don't have to go and ask, hey, what happens if I call this function with a 0? And one of the developers in the other room. No, you look at the test and it's like, okay, so it's supposed to be return a string. So I can expect that. I know what to expect. If I pass it a 0, I'm going to get an empty string back. So now you're starting understanding how the system that is there works. That's really, really important, because the hardest part for sure in software development is working with someone else's code. And by someone else's, I mean you yesterday, okay? Or last week, or last month. Existing code, legacy code that is there already, it's hard to work with. You'll see that. The first couple of days, I'm going to have you test code that you write. On day 3, though, we're going to give you some pre-written code, and you'll see that testing that is harder than the first 2 days. Just because you didn't write it. You have to go and read the code and understand what's going on before you, and we have instructions. Imagine when you're thrown into something that you're only reading the code and there are no tests. You're like, yeah, it's hard, okay? So testing is going to give you also the ability to understand code better. It's kind of self-documenting code when it's well tested. Questions? This that you see right here is there is this thing called technical debt. And it comes in many ways. But a code base with functionality that is not tested is a way to accrue technical debt on your project. If you have functionality there that is not protected by a good set of tests, you, my friend, have technical debt. And it's high interest rate, technical debt, because it's going to slow you down tremendously down the road. You're going to tell me, so why haven't we been testing from day 1? Well, because you needed to learn JavaScript first, and then you need to learn the technologies first, like React and Node first, and now you can go and test it. But going forward, when your personal projects, always try to, at least the core functionality, make sure that you always find a way to test it as you write it. As a side effect, This is contended, okay? And this depends a lot on the technology that you're using. But as a side effect, I strongly believe that the code resulting from writing tests first tend to be cleaner and lighter because it only introduces the stuff that it needs to work to do its work. Testable code is different from non-testable code. It generates code that is easier to work with, more decoupled. That is a side effect because you cannot. Let me say it another way. You can have pure functions and impure functions. And a pure function is something that is predictable. Given the same arguments, we're always going to return the same value. Very, very predictable. Also, pure functions do not cause side effects. Nothing else in your system is going to be affected when you execute that function. It's pure. It's not going to touch anything from the environment. So nothing unexpected is going to happen in the other corner of the software when you run that pure function. Pure functions are super easy to test. And as you start adding tests to your software, you're going to find yourself writing more and more pure functions. Because testing impure functions is a lot harder, sometimes even impossible. That means that testable code tend to go and have better patterns just by the fact that they are testable. So that's a nice side effect. Again, arguable. Some people say, yeah, but then you sometimes introduce abstractions that you don't need. Fair point. I'm giving you what I think. I think testable code is better structured and cleaner at the end. I am looking at the questions thread that may have been lost. So if you find it, please drop your questions there. But I do have, I just want to make sure that I don't miss any of the questions that are dropped here. Let me see. I see one. If there's another one, please drop it on the question thread so I can see it. Is it normal for testing to be a completely different role than develop? I've heard coding over, coding over the well. Yes. Yeah. Is it normal? Not on the modern teams, it's not. What happens is, we're going to mention that. We have different types of tests, but the one that we're going to always be expected to write is called unit tests. And the modern developer teams now, even if the job offers, they tell you, hey, we expect that you know unit testing. So unit testing is testing functionality for a unit. Doesn't mean like a single function. It could be a single class. It could be a single file. But a unit of functionality is what a unit test is going to test. Normally, that manifests itself on testing real small self-contained functions, pure functions, okay? Normally, but not all the time. But the point is that you as a developer probably going to be writing unit tests. Now, the other types of tests may be written by the team on the QA engineering team. There is a specific role that writes tests. QA engineers do that. They may do manual testing. They may have special software for different types of tests, but they can also write tests, end-to-end integration and unit tests. But as a developer, though, you want to walk away understanding the mechanics of unit testing. Don't worry about the other ones, but unit testing, you definitely want to know the mechanics of that. Doesn't mean that what you learn here is going to be what you're going to use on the workplace. They might not even be using JavaScript. They might be using a different testing framework, but the mechanics of it, that you will take, and you can use that on any testing framework that there is. We've come too far. We must refactor. Yeah, the famous rewrite. Never rewrite. Always incrementally fix. Testing are going to help you with that. All right, so type of testing. Well, unit testing, as I said, very small. They test a unit of software. This is what we're going to be writing today, tomorrow, and probably day 3. So you're going to get familiar with unit testing. You have integration testing. And integration testing is important because even though, and I think I have a link here somewhere that it's show you why integration testing is important. Maybe it's not anymore. Where's my integration test link? Oh, man. No, there was a link here. Anyways, so integration testing is going to take different units. Think about it this way. Let's say that for you, a unit is a component. How do you know that 2 components are interacting correctly? Well, integration tests will tell you that. But also, testing two components within a third component, you might be testing that third component as a unit. So there is a blur line between unit and integration testing that sometimes you cross it, sometimes you think you're doing one, you're doing the other. But the point is, integration testing is going to take more than one unit of the code, and that may mean that you're doing an API, okay, and then the API needs to access the database. When you're doing unit testing, you isolate the database. Oh, another property of unit tests is that they're, again, as we write and we want to talk about this, they're isolated, like pure functions. They don't rely on anything outside of themselves. So they're going to be very, very, very separate from the rest of the application. But when you do integration, like in the case of the database, you say, well, I'm testing my API, and when I'm unit testing, maybe I don't care about the database. I just fake that data from the database. But when I write the integration, I actually go and hit the database to make sure that my code is actually connecting correctly to the database, that I can add a record in there. And then I go and check to see if the record is there, to make sure that I add it correctly. That I delete a record and say, okay, is the record there? Yes. Now let me go and delete it. Test the code that I'm testing is the one that deletes. Then I go and check that the database, that the record is not there anymore. So in that case, now integrating two parts of the system, and there is a side effect. That is one of the properties. They're going to be slower, the integration, but they're also going to be side effects. It's something that is outside of the unit that you're testing. You're testing the code for the delete, but this is going to affect the database. So in order for you to test that, you have to be looking at the database directly to make sure that it was affected correctly. So integration test is a little slower. You're not always going to be writing those. QA might end up writing those, but know that they are, and we're going to write some of those on, I think, day 4. So you're going to have a taste of that, of having a test database and testing that. End-to-end testing go all the way, like I said, all the way from the front end all the way to the database and back. And if there are services, all of that is going to be covered. The idea here is a feature working, not only testing the different components that come together to do that feature, but at a higher level, I'm going to test the whole feature end to end. If that means sending emails, all of that is going to be tested in there. At the end of the day, those hardly ever you're going to be writing those. Most of the time, there's going to be QA. But if you have to write them, you'll learn how to write them. There are tools for that, okay? And this is crazy. There are tools that could even, spin up your application in a web server and do clicks and all that and hover over things. So you can script it. They tend to be very brittle. They break easy. So they're really hard to kind of write. But there are tools that will let you test everything about your software. There's a challenge there. That's fine. So what are we going to use today for unit testing? Questions there so far? Again, high-level stuff. Okay. So what do I need for that? What is the tooling around this? Well, let's concentrate on unit testing first. Unit testing, well, you need a testing framework, something that's going to take your tests and your code, and it's going to run your tests and make sure that software is working correctly, okay? So instead of me telling you all of this that's there, what about we go into the project and talk about today's exercise, okay? Before we do that, though, well, let's do it now. Let's go and go into the documentation real quick to see the software that we're going to be using. It's called Jest. Okay, so this is our testing framework choice. It is well, I dropped this in the wrong place right here. So a couple of questions there. How is it different from console logging? Hopefully you'll see that in the lecture as we write on test. It's different. You'll see it, Josh. So I'm going to keep that question there. And has the integration data science machine learning broken a lot of testing protocols? No, not really. Not really. Because at the end of the day, they both have units and they can be tested at all the levels. Unit testing, integration, end-to-end. Because at the end of the day, they produce a result and you can always test the results. So are object-oriented code bases harder to test? Yes, they are. They are. Object-oriented code bases bringing some challenges in the way that you architect them. There are things that you have to take into account. There are principles that you can follow so that your code is cleaner. So if you ever have to work with that, make sure that you look for something called solid principles, and you'll see something about interfaces there, and that's going to help you when it comes to writing testable code. You're going to be using a lot of interfaces. But out of the scope of our class, because we're in JavaScript, we don't have to worry about all that pain. JavaScript is a lot easier. Consider yourself lucky that you started on this language, because the other ones, ooh, people doing Java, they're going to have fun. A lot of fun. All right, so let's get started. So we need a framework. We know it's a package that we need to install. So the first step for me is going to be yarn add jest. Oh, by the way, this is just good for development. So how about we install this only as a development dependency? No need to send that code to production. Okay, so that's the first tool, and we're going to do a lot with just jest. Then tomorrow, as we start talking about testing React, we introduce another one, and then by Thursday, we're going to introduce the third one just for testing the API. All right. Looking at the watch, make sure that we have some. So what we're going to test is the easiest tests to write, which is some mathematical operations, because you could check the results easy, okay? So our test is we're going to have this calculator, and this calculator has an add function. It's returning null all the time now, so it's not working, right? So next to that, though, we're going to have our tests. So I'm going to try to keep this screen, see if I can have, ideally, I like to have this be like this instead. Let's see if we can feed it that way, and then having the response here. I wonder if we can support this resolution, or is it too small? Let me know, please. If it looks too small, let me know. If not, I'm gonna see if we can survive it this way. So on the right-hand side here, we're gonna have our console. And we're gonna have the output for a test running over there, okay? Now, Jest can be, we installed it, it can be configured different ways, because Jest can run tests in different ways and can do more than just writing the unit test. It could give you coverage and all that. So let's see what we need to do in order to configure it just to run our test, and that's it, just to run it, okay? We have this test script that we can use, okay? If you install it globally, you can run it from anywhere in the command line, but we're gonna use the same thing that we've done so far, right? We're gonna run it from a script. So all you need to do actually to run Jest, just call in Jest. If you do that, we don't have any tests yet, but just doing that, I can say yarn test. Okay, look at that. It's just telling me, hey, I found that you have this test suite, but it must contain at least one test. But that means that the tool actually worked. Only that after it ran, it just, you know, it ran, tried to run the test, and then went back to the command line. What we really want to do is we want to have that continuously running. Like every time we add a new test, we want it to run. Every time you change the code, we want it to run. So we can add a flag to this of watch, save that, and now when we run our tests, now we're going to get just watch. And this is what we get. Okay, there were no tests found, but it ran again. And you could trigger the test run by hitting enter, but it's still going to be the same thing. You don't have any tests yet. But it's watching, right? So if we go and add a test now, it will actually run it. Okay. Sometimes we have a problem when it goes to YouTube. All right, so let's make this a little bigger. Cool. Now, what does a test look like? Now that we know that we can run the test by doing yarn test because we added that to package.json, let's see if we can write a test for this. But before I run anything, I like to have a test that is like my sanity check. Can this thing like run tests at all? Okay, so I'm going to write a test in here, and there are different syntaxes from this. We're going to stick to one, but if you see that there is this thing, test is the same, right? So we're just going to say here, I'm going to say it, and then some text that is going to show up on the terminal there. It runs the test. Okay. So on it is what is called a test case. This is a test case. Ultimately, this is what you want to be writing. Okay. Now, a test case in here, normally you can think of it as 3 parts. Okay. The first one is arrange, and this is where you do your setup. Then you have another part called act, and this is where you run the system under test. This is the stuff that you want to test. In this case, we're going to be testing the add function. So this is where we execute that add function. And then you have an assert section. This is where you verify that it works. Okay. This is the thinking behind it. In a simple test, in most tests, you don't have to kind of break it up that way, but in your head, you're thinking, okay, what is it that I want to verify? So normally in here, I'm going to say, how do I verify something? Well, turns out that the library has some globals that you can use, some methods like this one, it. That's a global method that you can use. But there's another one called expect. So I could say expect, and this is going to have 2 parts. All right. This is an assertion. This is one of the most important part of writing tests. It's got 2 parts. It's got the expect that is going to take some actual value. And this is whatever you got as the result of running your system under test. And then outside of the expect, you chain a matcher. So I could say something like to be true. So if I arranged this saying something like expected or expected equals, let's say, true, and then I'm gonna execute some coding here. I'm just writing to have the motions here. Const, actual, and here's where you execute some code, right? And then down here, what you will have is actual to be expected. Okay. Of course, you're not gonna write everything that way all the time, but at least this gives you an idea of this is how I'm thinking about my code, right? I'm gonna have some expected value and some setup that I may need. I'm gonna get some actual value, and then I can compare the two. This is the syntax that matter on this example, right? Down there. See, I save that, and look, I ran the test. So that code, that little piece of that string there is what gets displayed down here. And this is how you start seeing how the system works. Okay. So the first thing we want to do is make sure that you can install just correctly, that you have a configure in your package.json for your test that is watching as you add tests and rerunning the test, and that the tests run correctly. So give it a try. Okay. This is the calculator. And okay, I want this to be like, not what I wanted. Okay, here we go. Like so. So we added jest, we set up this script to run the tests, and here's the test, and we haven't made any changes to the calculator yet. To run it, yarn test, that's it. Let me know if they run. I'm gonna go on a break. So if you're If you're not ready to go on a break, let me know so that I can stop until we solve any issues. Any questions? All right, looks like everyone has it. So let's take 5 minutes so that when we come back, we could go write test nonstop. Okay. So let's take 5. I'll see you in 5. All right. I am back. All right, let's write a test to get you into the groove of it. I was expecting to get a question along the lines of, how does Jess know that it needs to run the test? How does it find the test? How does it know that this is a regular file and this is the test file? Any ideas how that's happening? Yeah, yeah. So there are a couple of ways that Jess can use to find the test. Okay, this is important right here. So bear with me. If I have a folder anywhere in my code base, anywhere, I can add a folder and call it underscore two underscores underscore underscore tests underscore underscore. Any file that we add in there is going to be treated as a test, and Jess is going to try to run it. So if I come in here and say 1.js, okay, Jess is going to try to run it. You see right here that it says I'm running 1.js, but there are no tests in there. So I could go in real quick here and say, and let me show you another. See how the test got organized in there. Let me show you another little thing. Well, we'll do it on the other file. But the point, if I have a test in here, test. Remember that I told you could come on. You could use test or you could use it, and they both work the same. So if I add the test in here, it's gonna have an arrow function there, and say test from 1.js, and here say expect true to be truthy. Right? Save that. Oh, look at that, a different matcher. Now it's running and it's telling me they both pass. Okay. So any file inside of a underscore underscore test, and you can have as many of those as you need to, because it's a good idea to have your test close to the code that they're testing. So if you want to use this pattern of having this folder instead of just having a different file like that, you can just drop a test folder inside of the calculator and it's going to work the same. Okay, so you can have many of those, and every file inside there is going to be treated as a test. That's important. Don't add anything else other than test files inside of that underscore underscore tests underscore underscore. Another way of doing that is I could have, instead of a spec, I could have something here that says, calculator test.js. So anything that ends in .test.js or .spec.js is going to be treated also as a test. So by doing that, I created this file. You see, it ran and it's running 3 files now. And it's telling me the same thing. Hey, there's nothing inside calculator.test. So files name on .spec.js or ending in .test.js or inside of a underscore underscore tests underscore underscore. All of those are going to be treated as tests, and Jest is going to try to run them. Okay. So I'm going to remove all this. This is on, I think it might be on training kit, but it's also in the instructions. So I'm going to get rid of, actually, I'm going to get rid of the calculator aspect.js. Okay. I'm going to keep this one. The reason I'm keeping this one, moving away from what I normally do, is because I think on Create React App, they use the .test.js instead. So there you go. It works the same. Now, let's say that the user comes with a feature request and it says, hey, I want my add function to be able to add 2 numbers. That's our requirement right there. We need to write a test for that. Okay. The first thing is, what are we testing? Well, we're going to be testing the calculator, so we need to bring it in. So up here, I want to bring in the calculator out of the calculator.js file that we have in the current directory. So it will be like that. So this is exporting an object that has this add method, right? So we bring it in so that we can test it. Now, another thing that I'm going to show you is there is another global called describe. And it's a way for you to organize your tests. It's just like, think of it as like kind of folders. And the display on the right is going to be really helpful because now it's going to show you your tests, but organized by however you want to organize them. So let me show you what I mean. Let's say that I'm saying, okay, this is going to be a suite for the calculator. I'll make this a little bigger. It's going to be for the calculator.js. So I'm going to write a describe in here. The way that this works is describe, you give it some description like calculator.js, right? And then the second argument is always a function, could be an arrow function or a regular. Oh, yeah, that's not gonna work. It's here. Okay, like so. And now inside of this describe, you can even nest them. Let's say that I want to say, yeah, it's about the calculator.js, but this is particularly about the add method. So we could have another describing here. I think okay, describe that says, you know, the add method. And now every test that I insert in here, now it's going to show up. You'll see how the display is going to organize it and show me that this is the calculator, this is the add method, and then it's going to have the test in here. So the first feature is it should be able to add two numbers. So I'm going to write a test for that. I'm going to say, hey, it, and the way that you write it, the way that you phrase this is something that just should just make sense to you. Okay, so I like to use should, so I'm going to use that, but you could say can add two numbers, can add two numbers. That's fine. I like to read it this way. It should return the sum of two numbers. Okay, all right. So in here, what I want to test is expect that, and what am I calling? Well, let's do it in a couple of steps. I'm going to say, well, cons sum. I'm going to call it actual just to keep it with the format, but you could say sum is the same, right? It's just the actual value. It's equal to calculator that add, and let's say 2 and 2. Okay. And now we can expect, we can say expect sum, which is what we got, to be 4. And what am I getting this to be? Well, to be is what's called a matcher. And if you go into the documentation for Jest, you guys scroll all the way down, there is this expect area right here. If you click on that, I'm going to drop this on training kit, I mean on Slack, like so. If you see here, you're going to see a lot of matchers that they have. I have another thing. I'm going to drop this for you. Don't pretend for a minute that I know all those matchers. I don't. Okay. But this is a cheat sheet for Jess, and he's got whoever built this has a nice set of, hey, if I'm dealing with objects, hey, look at all the matches that I have for objects. If I'm dealing with, don't go into the mock functions. That may be tomorrow or Wednesday. But he's got a nice cheat sheet that you can refer to later. For now, just look at the documentation, and on the spec section, you see a whole bunch of matches in there. Okay. You're going to see a couple as we go to the exercises today. So let's save that and let's see what we get. Ooh, look at that. It's telling me, hey, I expected 4. See how nice this is now? This is telling me, all right, this is the file, and this is for calculator.js. This is the add method and should return. So you could read it like, oh, on calculator.add method should return the sum of two numbers. I like that. That's pretty nice. Okay, so it's telling you what the system is supposed to do. And then this is telling you this failed. Where? Here. When I try to run this matcher right here, it's telling me exactly which assertion failed. Okay. This could have more than one assertion. I could have something like expect sum to be defined. Okay. If I say to be defined, that's also another matcher that is valid. So instead of you checking weird things like, oh, no, you could just say, is it defined or not? Is it undefined or not? Is it null or not? You could check for null. If I say to be null, that would pass. So if I see now it's failing in this one, not on the first line. So the first one passed. So I could say expect this to be null. And that will pass because that's exactly what we're getting. We're getting a value. We're getting null back. So it is null and it is defined, but then it fails on the for. This is not what we expect. Okay. Let's get rid of all this. Keep it here. So how can I make it pass? Let me ask you a question. What is the easiest way to make this test pass? What would you do? Return 4. Yeah, that's the easiest way, right? If I return 4, excellent. Save that, and we're good to go. Here's the thing, though, and this is what purists, when doing unit tests, will tell you. If you're doing test-driven development, and I'll show you what that is in a minute. If you're doing test-driven development, do the minimal possible thing so the test can pass. I would say, yeah, be a little more pragmatic and think, what is the simplest implementation of a solution that you could have? So if I ask you that now and I say, okay, what is the simplest implementation for this solution? That would be a viable solution. It would be return, A plus B, right? We save that and we can see that our tests are, what? Return. Oh, the first thing is that we need to accept two arguments, A and B. Okay. And it works. It's perfect. Now our code is perfect, right? We can now rely on, okay, given that we pass two numbers to this function, it's always going to return the correct answer, right? Okay, let's write another test just to be a little more thorough, okay? So instead of doing this, let's call this method in here instead, right? Like so, because it's the same thing. Less lines of code to parse through, right? Shorter test. I'm going to say, oh, I'm passing, add 2 and 2 should be 4. But then what if I want to, just to make sure, let's add another one. Says, what about if I pass 2 and 1? Do I get 3? Okay, what about passing 0 and 1? Do I get 1? Right? Well, few things. Still passing two numbers because it's the sum of two. Oh, look at that. It failed. Oh, wait a minute. It's kind of weird because adding 2 and 2 does 4. 2 and 1 should be 3, right? Ah, a bug. See, this is why sometimes it is useful, even though we are still testing the same thing. We're testing the sum of two numbers. But just come up with a couple of examples just to avoid falling for a false positive like this one, right? Because this applies to multiplication and addition. But as we added a couple of more, now we can go and inspect and say, something's wrong with my code. I see what it is. Here we go. Now, if we fix that, hit save, and now we have a passing test. I feel a lot better now. The lesson to learn here is it's okay to have more than one expect, as long as the expect is going after testing the same thing. What you don't want to do, though, is test more than one thing on the same unit test. But as long as you're testing the same thing, you could have more than one expect, just to kind of guarantee that the code is working fine. Thank you, Brandy and Austin. I know. I meant to do that. All right. So go and write this simple method and see what it takes you. I'll give you a minute or two. Okay, everyone is good to go. So let's talk a little bit about something called TDD, test-driven development. And of course, you can read a lot about that. Good things and bad things. So I'm just going to introduce it real quick. With an image, look at that. That's it. That's all we need to know. The idea behind TDD is driving the development of your code by tests. Meaning, every new feature, you first write a test for it, and then you go and implement the feature. Kind of weird. Okay. So good though. So good. Okay. Of course, if you have existing code, that's not always something you can do. But if you have the ability, like if you have to do a change or implement a new feature, you could TDD it, even if you have old code, right? So the idea here is you write a test that fails because the feature is not implemented, okay? And then you go and write just enough tests again. Simple implementation that works. Okay, don't go and do return for. Okay, write just enough code to pass the test. We call that the green stage. So you're gonna mention here. People say red, green, refactor. Once you have the passing test, then you go and optimize and clean up the code. Because a simple solution, a naive solution, you're like, okay, I get it working now. Now, can I write this better? And that means writing the test better or writing the code better. So refactor is for both the code and the test. So the implementation code and the code for the test. You refactor it, but you are free to refactor as long as you have your test. Because if you break it on the refactor, you'll know the test is going to break. Okay? Someone introduced a middle step in there, and I like it a lot. He said, red, green, refactor, commit. And then you move to the next test. Meaning, every time you write a test with some implementation code, that means that you advanced something. Your code, you move the needle of, in the right direction. So do a commit right there. Because in working on the next test, you might break that. But now, since you have a commit, you have a point where the code is working and it's all good. So you can always go back and revert to that one commit. So I think it's pretty cool. But the TDD thing is red, green, refactor only. But I like the idea of red, green, refactor, and then commit. So adding a commit in there before you go into the next feature or test. You can't see the code, but you should be able to see the screen though. Can you see my browser with an image? And the reason is I asked and gave time. Nobody said no. I assumed everybody was good, right? So I moved into the TDD thing. So let me go back to the code. Questions about TDD before I kind of get away from this image. So please, as long as I draw that yes, no, tell me no if you still work on it, because that way I need to know that I need to wait for you. I don't want to leave anyone right in the middle of something. Here's the code. And I see two people still working on it. We are a team. So you have to let me know that stuff. You have to communicate. Team-driven development, TDD. Hey, that's good. That's good. Wow. Great minds think alike, huh? Joe and Anubai? Great minds think alike. Testing is easy, isn't it? Some people say that TDD is not test-driven development, but that it is test-driven design. Because it forces you to think about the design of your solution before you even write it. You're writing code and designing your system at the same time. I do like to have a high-level design before I approach code, though. So I don't know how that would work for me. Are we running into errors, Brandy and Austin? Getting this code to work? Ah, writing it out. Yeah, makes sense. K1. When you do that, I'm going to add a new feature. So it should return 0 when called without values. So I'm going to ask that you implement this feature on your own. So if you're working, if you're waiting, right, as everybody finishes, go write that code. Return 0 when the function is called without any values. How can you do that? That is a feature. So what we're doing now is we're going to write a test first. So this is TDD. And then we're going to go and implement the feature. So Nick is like, oh, I saw TDD. I thought it was like technical design documents. No, now you know what it is. So when you're called in for an interview now and they talk about TDD, you were like, yeah, I know what it is. Yeah, I've done some. Yep. I'm not an expert at it or anything, but I've done some. I know how it works. I could talk about it. What does the error say? And did you get an error on this? So if we have this, only this test that says runs so if you only leave that one test in there, does it still give you error? If you have a passing test, a failing test is going to show you on the terminal. It's going to tell you what it is. It should have some kind of display here on the terminal. What does the other say, though? It should be telling you something. It should be telling you something in green and red that says, this is what I expected. This is what I got. So it would look like this. If I change this to say 5, save that, it should give you something. It should tell you expected this and got that, and it's going to show you the line which assertion is failing. It's not going to tell you how to fix your code, but it's going to tell you what assertion failed. Let's see it. Can you share? Stephen Jefferson, you're in charge to helping us fix that error. It's like, yes, thank you, Luis. That's exactly what I wanted to do. Josh, are you there? If you can please unmute Steven so he can walk us through the solution.
Sure, 1 second.
Thank you. It says to pass though.
Yeah, it looks like it passed.
Yeah, well, she commented out the test.
Um, yeah. Um,
Hey, good job.
so it instead of if. Just a typo.
Yep. All right. Good job. Typos, the bane of developers. All right, so what about this feature? Anybody has a solution for this one right here? Return 0 when called without values. I want to see the test. Can anyone share that on Slack? So how do we become experts on all of the stuff that we only see introductions here in school? By practicing and looking at other resources for sure, but I think building projects is what gives you that expertise. So the build weeks, the labs project, those are going to help you become more comfortable with it. But of course, going into the documentation and looking for external resources with more advanced topics for it, they're going to take some time, right? Because getting to the advanced stuff is not going to be it's not going to happen in an hour or two. But you could slowly learn like one or two things every day until you become a lot stronger of any concept that interests you more. Authentication, testing, whatever. Time is the only medicine for that. All right, so let's see. We have some interesting implementations is there. Let me grab the first one there that showed up. It says, it looks like this. Okay, so what this is saying is it should return 0 and call without values. Perfect, I like it. Expect the calculator at, well, without values would be without values, like so, right? Totally empty. To be 0, that test looks good. Only that now all hell broke loose in here. Oof, I broke everything. So let's see. What does it say? Well, the first one is because I changed this. So we can fix that real quick. And now we should have only one. There you go. We got not a number. Ooh, that's not good. So let's see if we can fix that. And I see a lot of good stuff here. Like, yeah, if they're not values, whatever. I'm gonna use a feature of the language to fix this. Okay. As a way to minimize the code and use the features of the language. So I'm going to say, if I don't get any value for A, make it 0. If I don't get any value for B, make it 0. Save that and see if that fixes it. Oh, there you go. We're good. Okay. So one little tweak to the test, instead of passing null or undefined, because that's no values. But that brings an interesting point. Remember that thing of, I don't know what to test. It's going to be the hardest part. Take the easy way out. The low-hanging fruits. Think, if everything is fine, what is this supposed to do? That's called the happy path, right? The happy path. If this is a function to add two numbers, the happy path is given two numbers, what does it do? Add them, write that test, the happy path. And then you're going to start getting ideas. That gave me an idea. What if, and this is you, Mario, you gave me that idea. Passing null, undefined, an array, an object, a string. What happens then? Because you should never trust other people's code, even if you write the other code. You're protecting your system under test, your function in this case, you're protecting it. You're saying, what if they give me that? What if they give me only one number? What do I do then? Let's write it. Let's write a test. Let's say, let's try the last one. Should return if only one value is provided. Can you write this test for me, please, and drop it on Slack? So you just have to copy it. Give it a try, please. Take a minute. Later, in a few minutes, we're gonna do an exercise where I'm gonna give you something a little harder to do. But instead of I'm giving you, I'm gonna give you about 3 minutes to work on it. And then I'm gonna do some breakout rooms. And then I'm gonna give you another, I don't know, 3 to 4 minutes to do a discussion in the room between all of you to see the solutions that you came up with. Or if you haven't, just to discuss, see if you could come up with a solution. And then one of you just drop it on Slack at the end. Okay? So, Ooh, that's nice, William. That's a nice test. All right, so let's see it. All right. I'm not giving you enough time to finish it because we're gonna write it here in front of everybody anyways. But this is nice. And we're doing TDD here, right? We are changing our code, but instead of going and implementing the solution in the code, we are first writing a test for it. And the test is the one demanding that we go and change the code. Because the test starts failing. We want to see that red, and then we want to implement it, okay? This is TDD in practice right here. So look at that. He did like the 3 parts. It's like the expected is 100. I'm going to get a result by calling that. And then I say, I expect that the result is going to be the expected. That's beautiful. Okay. This is your thinking. Even if you condense all of that into a single line, and we haven't done, this is in your head. This is how you conceptualize it. Cool. Only that is failing. We need to make a pass now. How can we make that pass? Anybody has a solution for that? Oh, I don't know why. Calculator. Here we go. Oh, look at that. It passes. Ah, man, I wanted to kind of do something drastic with it to make it pass. Let's just try another one. And now, let me show you this, right? We wrote a test for this, for only one number. We wrote that. But if we look at this, what is it that we're saying there? I mean, we could write different tests for all of this, but sometimes if you look a little deeper, kind of squint a little bit at it, you kind of get some insight. What is all of this saying? Can you tell me? Yeah, that it should attend back data. I think Christian got it, right? What we're really saying is, what if they pass me something that is not a number? Right? Probably that's what it's saying. That is not a number. So we could write a test for that. And check, if the arguments are not numbers. If you give me an object, that means that that's going to fail. So I'm going to leave you that for you to do it on your own. Just check. Because I want to change this to be a little more robust, right? The function add. So instead, I'm going to give you an exercise. I'm going to give you 3 minutes so you think about a solution on your own. Both the test and the solution in the code, right? 3 minutes. It's not going to be enough. Trust me, it's not going to be enough. But at least it's going to get your brain going on the exercise. And then I'm going to break you out and give you another 3 or 4 minutes for you to talk to your peers and say if you come up with a solution, at least a strategy. And it doesn't even have to have the code because you're not going to have enough time to do it in 3 or 4 minutes, even in the group. Okay. But at least some pseudocode, some ideas. So I want to foster the discussion among you. Like, let's talk about this. How can we approach this test and the solution? and then we're gonna come back. So it's gonna be an exercise of about 10 minutes. 3 on your own, breakouts, 4 or 5 minutes, 3 or 4 minutes, and then coming back here, 10 minutes to have you thinking about this. Okay, here's the mandate. Here's what I wanna be able to do with this add function. Add any number of arguments, not only 2. Okay, and any number of arguments. So this implementation that we have of A and B is not going to work anymore. So take 3 minutes and see if you can kind of have an idea of how to test it and how to implement it. Some algorithm practice here. So here we go. Our function should add any number of arguments. Separate it. Oh, let me make it a little nicer. Separate it by commas. Don't worry about checking that there are numbers or any of that. That's going to add extra complexity in there. Just assume that you're getting a list of numbers separated by commas. Through that. 3 minutes. Just give you a timer to have an idea of where we are. Look at the exercise. Implement only the requirement is given a list of numbers. Don't worry about not the numbers, none of that. Given a list of numbers, should return the sum of them. Get used to this approach of incrementally adding features. Concentrate on one and then another and then another. Because remember, you're going to have tests for this. So when you move to the next step, those tests are going to tell you whether you broke something or not. All right. So some of the PMs may end up in your groups. I'm going to ask the PMs to you could join and be there or just not join. It's fine. Okay. So here we go. Remember, just talk about possible solutions. See if you can write the code even better. If you already have some code, share your screen. That's the idea of this, a discussion amongst all the developers, you and all the developers. Here we go. See you in about 4 minutes or so. Anybody still on the main channel has not gotten the pop-up to join the breakout rooms? Everyone should be back here in about 30 seconds or so. All right, I think we're all back here again. Missing two. There used to be 55 of us. I think everyone is here. So, any of the groups have some code for the test that we could share with us here in Slack, please? Anyone? No? Okay. Any of the groups have some pseudocode or something they want to share with us? Like, what do you talk about? If you drop a thumbs up on Slack, Josh can unmute you. Timid? No one? Really? All right. I'm gonna ask okay, Irving. All right, so we have something for the implementation. What about the test?
Can you hear me?
Yep.
Yeah, so a bunch of people were like writing stuff in the group. I guess you couldn't see it. I can't. Okay, sorry. I can share my screen real quick.
Yeah, can you walk me to it so I could type it here for everyone? Is
Okay,
this
yeah.
well? No, you can share. You can share. All right, let me show. And I'm gonna have you just explain it.
Sorry.
That's awesome. That will show up in the video.
All right, so I have this. I just wrote it out similar to the other ones, copied and pasted, and then just added more numbers into it, and it works.
Okay. Yep, that works.
And then this is like the calculator.
What is those dot thing up there, and why does that
It's
work?
in like whatever numbers, like more, like whichever amount of numbers it receives. Similar, it would be, I imagine it's similar to when you're doing props and you're receiving like a whole bunch of props.
So
Or
if I
like
need to do a search on that, what would be that feature of the language that you're using there?
I mean, it's JavaScript, no?
It's called REST parameters. But yeah, that's a good implementation right there. So what he's doing is he's got he's taking, okay, any arguments that you have, those they're used for the spread operator, but they also use for the rest parameter. And this is something that you could have as the last argument on a function, right? And it's just saying, whatever parameters you give me, I'm gonna grab them all and give you an array with that name. So what that's taking is it's taking all the arguments there and give you an array called numbers that has all the arguments. Since it is an array, you could do what he's doing on line 10, which is called reducing it. And reduce is missing, like if I was implementing that, let me just kind of implement it here, looking at his code. So he called this numbers, okay? And then in here, instead of what he's doing is say, okay, this is an array now, so I can just say number. One of the functions on an array is reduce. And it takes a function as a callback as the first argument. So this is what he got right there, right? But then the second argument of that should be, what is the default value, the first value that the value where you're gonna start at. So make sure that you pass that 0 there. Otherwise, you're gonna be starting with undefined.
So I have to pass a 0 at the end?
Yeah, as the second argument on the reduce, right? The reduce has two arguments, the function up here, and then the second one is the first value for the accumulator. Because what a reduce is going to do is going to take a collection of something and turn it into a single value. It doesn't have to be with numbers. It could be an object. It could be with arrays. But you always need to start somewhere. What is the first value? Because what it's doing is on the first iteration of this, it's going to take the first value as it's got two arguments here. It could have more than two, but the first two arguments are an accumulator and an element, okay, on the array. So what happens is you have this accumulator. The first time you have nothing, it would be undefined. And then inside the body, you could do operations now. And you could say, normally what you do is you return something. And normally you will see like this, the accumulator, and then some kind of operation. In this case, it would be plus the element. But the first element in the array, though, what is the value of the first element? Well, if you're testing with, I think, let me say that I'm passing calculator that add, and then you pass like 1, 2, 3, right? And then this to be 6, like so. If you're passing 1, 2, 3, the accumulator the first time around is gonna be what? Undefined, right? There's no value here. You haven't accumulated anything. But the first element is gonna be 1. So this would look like undefined plus 1 with this collection right here.
Should I stop sharing my screen?
Oh, yes.
I just realized, yeah, because you're probably.
Yes, nobody's like, yeah, and I'm not looking at Slack. Yeah, that's bad. Okay, again, let's try it again. Let me move this window out of the way. Let's try it again. So if you're testing this with 1 to 3, right? What happens is you have this accumulator, and the accumulator has the function. The first argument is going to be that function, and then the second argument is what is the value that the accumulator is going to take the first time on the first iteration here. Because it's going to do this, reduce is going to be a collection converted into a single element. So it's going to go through all of the elements. The first time is going to be undefined plus 1, right? Because the accumulator has no value yet, unless you pass a second argument. So by passing that second argument, now the accumulator is going to be 0. That first time around is going to take this argument. 0 plus 1 is better. In this case, it's not a big deal. But in some cases, when you're working with arrays or objects, it's a big deal not having something to begin with, okay? This could be you working with an object that you're just merging things into. So always make sure that you provide that first value for the accumulator for the first iteration. And then whatever you return out of that becomes the accumulator for the next iteration. So if the first iteration was like that, in the second one, right, this thing right here becomes the accumulator. Okay, so on the second iteration, it would be the accumulator. There was a value of 1 plus the second element, which is 2. And then that becomes the accumulator, right? So that would be 3. So now the next time, the accumulator is going to be 3 plus the 3 from the element. And that's going to be now the result. Because that's the last element. So that's how, now this is kind of a review of how the reduce works for everyone. So this works nicely, right? So I'm going to throw a wrench. I know that we're almost up to the hour, but I'm going to give you another. What about add support for handling arrays of numbers? Okay. So it's going to look a lot like this. Like this one. I'm going to give you the test right here, right? But I want to test it passing an array instead, like so. So if we do that, what are we going to get? Oof. That's not what we expected, but this is what we get from this implementation that we have there. So take 5 minutes and see if you can make it pass. And as soon as you have it, just drop it on Slack for us to see it. Go. This is what it looks like now. me take formula counter. There we are. This is like a whiteboarding exercise for you, but only in code. I want to give you a hint. Remember that there is an arguments value. You have access to. I'm going to stop here just because of time constraint. The idea was not to get you to finish the exercise. It's hard if you haven't done it before, right? So it's not, you're not going to do it in 2 minutes. The idea here is, this is what it looks like to build software, okay? You have a feature, and then over time, and we're doing this within minutes, but this is something that could happen over months. Over months, some good business idea shows up, and then you need to modify your software to support that good business idea. And they're going to come to you and they're going to say, hey, here's what we want to do now with the company. Can the software support it? Can you fix it somehow so that it supports this new cool thing that we're going to launch, right? This is what it looks like. And if you didn't have tests after building, 500 features, and you have to add that one or modify an existing feature, and you didn't have tests, you will always have that nagging feeling. And did I break something else? One of the other 499 features, did they get broken somehow? There may be interdependencies. But having the test is just what happens. Someone wrote there, what if I do this? What if I change this and just kind of, do something like this? That might work, but I don't know. This is going to tell me, yeah, no, doesn't work. We broke the test. So, okay, so I know that doesn't work. What can I do something else instead, right? But the test is the one that's going to tell you whether you broke something or not. So let's do a quick implementation of this. Who knows how many ways of doing this there are, right? So I'm going to do something like this. I'm going to say I'm going to get some arguments here, okay? And then whenever you have a set of arguments like that, there's an arguments collection that you have access to. It's not a real array, but it's iterable, meaning that you can convert it into an array. It's like a fake array. It's a collection of elements called arguments, right? So you could use something like that. So I could say const numbers, and then say, hey, I wonder if what they give me is an array already. So you could check for that. You could say array that is array, and then say, are the arguments already an array? If that is the case, well, I could just use them. So make numbers be the arguments because they're already an array. But if not, if they're not, then what can I do with them? Well, I could take the arguments collection and generate an array from it. And there are different ways of doing this. You could say array from and pass the arguments. Okay, this is given by JavaScript. It's always going to be there. This is going to be a collection of all the arguments that you have in there. Or you could just do what you wanted to do, which is this, right? You could say, I'm going to generate a new array, passing in the arguments. Not the args, but the arguments. Okay, so either way works. Now, if that's the case now, that means that I'm going to have an array either way. Either it is already an array and just use that, or I turn it into an array here by using, and this is not the rest parameter anymore, this is now the spread operator. I'm taking that collection of arguments and spreading them inside of a brand new array. This is a brand new array that I'm creating on the spot. Save that, and voila, it works. Okay? But what's important here is not the code. What's important here is the mechanics of you're going to be given new features, but I am okay now implementing that code because if I broke the other one, the test would tell me, yeah, you support arrays now, but now you broke the separated by commas. Right? Questions so far? This is the simplest way of writing unit tests. Writing unit tests against pure functions that you can always pass different arguments and you're always going to get the same result back. It's not always this pretty, okay? But this is a good start. So what you want to go now is I'm going to show you something that you're going to need for today in the afternoon. And that is, if I write a test like this one, okay, to be or not to be. Okay. And then we say, well, I expect true not to be false. Okay. If we run that, missing a dot there, should pass, right? To be or not to be. That's one. But then the other one is, look at this. This is interesting. Expect an object that has a name of John to be an object that has the name of John. Save that. And it fails. And it fails on there. You're like, they're exactly the same. But they are failing because the to be is a strict operation. It's checking the actual reference. They're not the same object. They're two different objects. Same with arrays, right? So for that case, there is another match that you use, which is to equal. Okay, save that. To equal is a deep equality. It's going to check the properties of the object, not the reference in memory. So make sure that you have the difference between the to be and to equal clear. You're going to need it today. I could have written a test for this. I could have written that. There are different tricks. Like if you don't want to do this to equal, you still wanted to use to be, there is a trick for this. I could say, you know, let's say that this is an object right here, because you're probably going to have this in an object, say const person equals that, right? I just didn't want to do that in there because it's going to look weird doing it in there. But I could say person that name, right? Nothing's stopping me from doing that. To be John, right? And I can still work with that object and still use to be. Just need to say what I really want to know is if it's the same name, okay? If that's what you care about. So this is a lot cheaper than this one because it doesn't have to do that deep equality. You could just give in two values and now you are comparing two primitives. It's a lot faster. But know that you have a lot of matches. Go take a look at them. Look at the cheat sheet and you'll see a lot of matches that you can use for the project this afternoon. Questions? All right. Go write some code. Go write some tests for this, for the code in the afternoon. As many tests as you can think of, just write them, right? If you have an idea, oh, what if I happen this? You have to write a test for it and see if you can implement it, okay? So remember, First step is you need to export from your code, and you need to require that into the test so that the tests can use your code. Someone posted a code that only had the add there. Yeah, that's easy to do. All you have to do is you destructure that and you bring the add out of it if you're only testing one method, right? We didn't set it up that way, but that's also doable. We set it up by bringing the whole object back. If you don't have any more questions, that's it. That's all we have for today. Quick introduction to TDD, and use TDD in the afternoon. Write your test first and then go and implement it. Write another, then go and implement it as you get ideas. Cool? All right. Have a good one. See you in Slack.